Happy day to everyone. Welcome to Stan Academy. Today we're going to discuss about chapter 8 motion part 2 from class 9. Scalar and vector quantity. Let us consider a line segment A to B, the line which specifies the length L. This length L from A point to B point, which is nothing but line segment of length L, and AB has no specified direction. That means there is no specified direction when you are seeing this diagram and this diagram. So what it tells here in this diagram, the direction of this line segment which is from B to A, and this diagram we can see from the direction point A to B. That means this first diagram only tells this magnitude level of the length. That means if suppose you are considering 5 centimeter, right? So 5 centimeter means how much? That is 5 is the magnitude value. So it is coming under scalar quantity. And here also we are considering the same length 5 centimeter. But what is the direction of this line segment? From point B to A. So from point B to A. And third figure, it is also coming under vector quantity because of reason it directed towards from point A to B. So the length of the line segment which specify the magnitude and also the direction means we say that quantity coming under vector quantity, and here only you are considering the magnitude alone means it coming under scalar quantity. So very important note, vector BA is not equal to vector B as their directions are different although they are equal in magnitude, right? Here the direction is in opposite, but here the magnitude, the length of the magnitude is same. Okay, then for two vectors to be equal, both direction and magnitude should be equal. So two vectors means, see here again the point A to B, we are considering the same length of the line and it is directed from A to B. Another point, another object, if you are considering A to B, which is equal means we have to consider it is a parallel vector direction. Okay, since both the vectors are equal in magnitude but just opposite direction, we can write the vector AB is equal to what? Minus of vector BA. That means 5 centimeter, which is equal to minus of 5 centimeter. Okay, right? So what it means, you are specifying a particular direction. You are specifying a particular direction. I hope everybody understands the scalar and vector quantity because this is very important when we are discussing the physical quantities of distance, displacement, speed, velocity, acceleration with respect to time. Now we are going to discuss about related numericals. Let us listen. An object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. Here you are going to consider an object at point A, right? So what is this point says? Initial position, right? It is a initial position. And you're going to move from this point to this point, okay? This point to this point. And again, your tends to move from the direction of B to A. That means this point to this point. My question is, what is the total distance you have covered? The total distance you have covered, that is from this point to this point. See here, from A to B is what? AB plus BA plus BA, right? Okay, so what is the total distance you have covered means if I am asking question, it started from initial position and you get again you are ending in the final position point A. That means AB plus BA, right? But the question what they are asking, an object has moved through a distance, can it have a zero displacement? Obviously yes, because you know where it started, the displacement is nothing but shortest distance between initial position to the final position, right? But the distance, what we are saying, total distance covered by an object. That means from point A to B, again B to A. Then definitely the displacement will be 0. That means shortest distance is what? The displacement initial position to the final position. So where it is started from A point, again it is ending A point. So the displacement between the shortest point is what? Initial to the final. So displacement definitely this condition we can say it's 0. It may vary for different situation. So the answer is what? Yes, zero displacement is possible if an object has moved through a distance. Suppose a ball starts from point A and return back at the same point A. Then the distance will be equal to 20 meters. So suppose you are saying this is 10 meters from point A to B, right? And again it is from B to A is 10 meters. So what it means? The total distance covered by the ball, it is 20 meters. While displacement, definitely it will be 0 because displacement is what? Shortest distance between initial position to the final position. So displacement is 0 because it is started initial position and ending into final position. So again it is ending in the same point. Question number 2. Find the distance and displacement from the given figure. We already discussed in the previous slide, that is part 1. We know this boy, he want to go point C. Okay, so he started his journey from point A to B. Again, he is ending point C. So the question what we are asking, find the distance and displacement from the given figure. It is very easy to understand. You know what is the distance? What is called distance? It is the total path traveled by an object. So they have given the value also from point A to B and point B to C. That is total distance covered by this boy is nothing but 7 meters. Okay, then displacement is nothing but, you know, the Pythagoras theorem we have to use, right? Then c is equal to c square is equal to a square plus b square. Then you will get the displacement of this boy is 5 meters. So you have to analyze how much of the distance covered and how much of the displacement we have to consider for given condition. Uniform motion. Uniform motion, so far we have discussed about distance and displacement. When you're coming to the point of uniform motion, we have to consider the object or any car which is moving from initial position to the final position. We have to consider the speed and also the distance. So now we will discuss about detailing what is called uniform motion. If a body covers equal distances along a straight line in a regular intervals of time, then the motion is said to be uniform. This is nothing but when you are seeing this car, see here, this is the initial position of this car. It is started with the speed 10 meter per second. So after it is covering a 5 kilometer, okay, 5 kilometer from this point to this point, right? Again, this second distance, if you're considering 5 kilometer, same distance interval, and what happened to the speed? Again, it is 10 meter per second. That means it is carrying a constant speed for every distance, right? So this condition we say it is a uniform motion. For body covers equal distances along a straight line in regular intervals of time, then the motion is said to be uniform. So example, also we can say a ball is posted in free space will continue to move uniformly, covering equal distances in equal intervals of time along a straight path. Then if an ant also it covers equal distances in equal intervals of time along a straight wire, its motion we called it as uniform motion. And a car is running at a constant speed, say 10 meter per second, will cover equal distances of 10 meters every second. So its motion will be uniform. Next, we are going to discuss about non-uniform. So, non-uniform motion is nothing but if body covers unequal distances in regular intervals of time. Regular intervals of time means 2 hour, after a 2 hour, what happened to the distance covered by an object, right? So, example, a ball takes a curved path. See here, a ball takes a curved path like this when thrown. Its direction of motion changes with time. Also, it covers unequal distances in regular intervals of time. So, its motion is non-uniform. The ant is moving on a circular wire. It is traveling equal distances in equal intervals of time. But its direction of motion is not constant. So, its motion is non-uniform. So, next we have speed. Speed is nothing but the distance traveled by a body in unit time. That means The body which covers the equal distances per unit time. See, this body carrying a speed of 20 km per hour. After this 20 km, the distance it is covering 20. So what it means, 20 divided by 1 hour. So the speed we are saying 20 km per hour, right? So if a body travels a distance s in time t, then its speed is v is equal to, mathematically we say s by t, and SI unit of speed is meter per second. Also we can say kilometer per hour. And if you want to convert kilometer per hour, that is 1000 kilometer divided by 3600 seconds. That means 1 kilometer upon 1 hour, which is equal to how much? 1 kilometer is equal to 1000 meter divided by 3600 seconds, because 1 hour is nothing but 60 minutes into 60 seconds. So you can directly take it as 10 by 36. Then you will get 5 by 18 meter per second. Then you have to multiply with 5 by 18 when you are converting 1 kilometer per hour into meter per second. Right? And since we are considering only the quantity, that means only the magnitude value of the speed, so it coming under scalar quantity. Okay. Then how we are finding the average speed? Suppose you are traveling from your home to any destination place, like if saying Chennai to Kanyakumari. So how we can find out the average speed? It is nothing but it is a ratio of the total distance traveled to the total time taken, or we can write it as average speed is equal to total distance by total time taken. Some numerical we will discuss now, then you can understand easily. A car travels 85 km from point A to B. So point A is here, okay, then B is here. Okay, car travels 85 km from point A to B. So what is the distance it is covering from A to B? That is 85 km, right? Again, it travels from point B to C. It covers 45 km. Means 45 kilometer. So the question what they are asking, what was the average speed of the car? But the total time took was 1.3 hours. So from point A to C, what is the time taken by the car? It is 1.3 hours. Okay, 1.3 hours. Then we can calculate the total distance traveled by a car and total time taken from initial position to the final position of the car. So total distance covered from A to B is 85, and from B to C is 45. Then 85 plus 45 is what? 130 kilometer. The total time taken by the car is 1.3 hours. Then you can directly divide it. You will get 100 kilometer per hour. Got it? Next, velocity. So what is the difference between speed and velocity? We have discussed about the speed. Speed is tells only the magnitude value. That means only we are considering the magnitude, but we are not considering the direction. But when coming to the velocity, we need to consider the direction as well as the magnitude. So velocity is nothing but quantity which specify both the direction of motion, and speed is what? Velocity. Velocity of the body is nothing but displacement of the body per unit time. You know what is displacement? Shortest distance between initial to the final position, and what is the time taken by the object, right? So that is velocity. Since velocity has both magnitude and direction, this is very, very important. So it is coming under vector quantity. So again, average velocity. Average velocity is nothing but it's the ratio of total distance to the total time taken. Then we can write it as total displacement divided by total time taken. Average velocity is also the mean of the initial velocity u and final velocity. Then initial velocity plus final velocity divided by 2, or u plus v by 2. Speed and velocity have the same units, meter per second. So now we will discuss related to that speed and also velocity. Now average velocity, how we are finding. A person walks from 4 meters east in 1 second. So the person, just consider this is east direction, this is north, and this is south, and this is west. So you have to consider the direction of this person walking, right? A person walks 4 meters east in 1 second. So he is walking from, he started from this point as an initial position, and he is ended this point. So we can take this is A, and we can take this is B, and he is ending this point C, right? So they have given clearly 4 meter he is taking from point A to B, and it takes the time is what, 1 second. And this point, he is moving from east to north direction, so he is moving from east to north direction. Then time also taking 1 second from B to C. So what is the average velocity he has completed? That means displacement at time elapsed. That means how much of the starters the distance between the point of initial to the final, and how much of the time elapsed he has taken. Then 5 meter, that means 4, that is 5 meter. How we are finding? That is using Pythagoras theorem. Then you will get 5 meter divided by 2 seconds, you will get 2.5 meter per second. Thank you.